Hello everyone. Today let's go over a medium question that I just solved by myself. This one is pretty simple. It's called difference in number of distinct values on diagonals. So this description is a little bit confusing, but it's manageable. Essentially, if you look at the diagram, it makes more sense. For a grid, let's take an example. For cell 0, 0, which is the top left, you would calculate the length of the set of this versus the length of the set of the top right, which doesn't exist, so that's 0. So in this case, left above is nothing, and right below is 1, actually, because there's one element in terms of the length of the set. So absolute difference of 0 minus 1 is 1. And you essentially do that for every single cell. So for this, it would be 0 minus 1 is 1 again. So for 0, 1, the answer is 1 as well. And for 0, 2, there's nothing below and to the top left, below right. So the answer is going to be 0. And you just do that for every single cell in the matrix from left to right, row by row, from top to bottom. So knowing that, let's code it up. Let's create a result grid that's going to be a copy except filled with zeros. So let's define the length, the width of the grid, and also the height of the grid. So this is going to be 0 for I in range n. So getting all the rows, 0 times m. Let's print the new to see that it works. Okay. So, so if m is the length of the grid, so this is supposed to be opposite because we want n is 1, 2, 3, 4, 5. M is vertical. So now let's iterate over the grid and do exactly what we said. So left to right, row by row. And let's call this left up x, left up y, because we're going to find the coordinates of everything that's possible up to the left. So that's going to start at I minus 1, j minus 1, right? Because this is coordinate 1, 0, this is coordinate 1, 2, or this is coordinate 0, 1, and this is 1, 2. For example, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 4, 4, 3, 3, 2, 2, 1, 1, 0, 1, 1, 0, 0. So if you notice the pattern, it's just plus 1 to both x and y, and minus 1 to both x and y. So right x, let's call this right down x, right down y is equal to I plus 1, j plus 1, row, column. And then now let's call this left up set and right up set, because we want the set. We don't want to count duplicates. For example, this is supposed to be 1 because they're the same element. So now let's do exactly what we said, which is to say if left up x is bigger than or equal to 0 and left up y is bigger than or equal to 0, means we're not out of bounds to this side of the grid, then we can add left up set dot add the value of the grid, right? Because we want to count the length of the set of the values. We want to make sure the values are not duplicate. So grid left up x, left up y, and then obviously we have to subtract 1, as we said, in every turn until this loop becomes false, which means we're out of bounds. Do the same thing with right. So right down x is less than the length of the grid, which is this way, and right down y is less than the length of grid 0, which is the width of the grid. Then right up set dot add grid right down x, right down y. Same thing, right down x plus equal to 1, right down y plus equal to 1. And by the time we finish, we know that we've went here and went here. And now we can say the difference is just the length of, or the absolute difference, which it says right here, absolute difference of the length of left up set minus the length of right up set. So that would be the answer for the current cell, which is 0, 0. So then new is the copy of the grid, so we can just say new ij is equal to difference. And then at the end, we can just return new. And there you go. It works and it passes all test cases, so pretty straightforward. And just testing the knowledge of if you know how to manipulate diagonals on a 2D matrix, on a list of lists of integers in Python. So hope you enjoyed this video, and I hope this was helpful. So please consider subscribing if you do, and please stay tuned for more content.